Hello, friends. This is the AlphaList podcast. I am your host, Toby. The goal of the AlphaList podcast is to empower CTOs with the info and insight they need to make the best decisions for their company. We do this by hosting top thought leaders and picking their brains for insights into technical leadership and tech trends. If you believe in the power of accumulated knowledge to accelerate growth, make sure to subscribe to this podcast. Plus, if you're an experienced CTO, you will love the discussion happening in our Slack space where over 600 CTOs are sharing insights, or visit one of our events. Just go to alphalist.com to apply. Welcome to another episode of the AlphaList CTO podcast. Today's guest is someone who's been optimizing energy systems since before it was cool. Barbara Wittenberg. So is it cool right now? I'm not sure. I guess yes. And Barbara Wittenberg is the CTO of 1,5, where she's driving the tech for decentralized energy systems, digitizing the craft sector, and making smart energy actually smart. Was that a good introduction, or do you want to add something?
That was a very good introduction, other than, of course, it's cool. Because today, that's a topic that can scale. And I think we can talk a bit about the past and how I came to being in the position of now really optimizing more than 40,000 assets actually online. But today, it's a cool thing because it scales and it has impact on consumers. If you go back to the start of it, then maybe it was a little less cool because it was more techy and done in a cellar and you couldn't really bring it outside to customers. But for sure, now it's a cool thing.
And I can imagine that it's also like super good to find employees in that space, right? Like everyone is kind of wants to have like a meaning in life and wants to do something good. And in a way, I mean, it's business, obviously, but you're also like pushing for something that is obviously good for the world. Is that correct, or?
That's a correct assumption. I think we haven't struggled yet with finding the right people for our mission because of what you said, right? You can still join a company that's growing. You can work in a super cool and modern tech environment, and yet you can have an impact on with what you do, and you can see how many CO2 emissions you are saving your customers and really provide cleaner and cheaper electricity then.
Cool. And before that, you worked at Google and Oracle in like sales positions, and now you're a CTO, like acting CTO in an energy company. Why is that? Like what's your history?
I think to understand that a bit, we need to go back even further, probably even to the times when I was still in school. Because originally I studied electrical engineering and economics in Aachen. And that came because during my school time, there was an electricity outage in parts of Germany due to a snowstorm, and nobody could get electricity back online for a couple of days. So I was stuck at home. My tests in school were cancelled, and I was really wondering about how the heck can nobody solve the problem, right? It can't be that difficult.
I want to solve it.
Yeah, so that's basically what happened. So I thought about, what do I need to learn to be able to solve those problems in future? Then I searched for that. I started searching for that online. I searched for what are the best universities to go and learn that. And like that, I ended up in Aachen. And then actually in Aachen, I did a lot of energy system modeling programming, a lot of optimization of energy assets to what the grid needs and how to get more renewables into the grid. That led me to actually start my career in E.ON. So originally my career started in the energy industry, and in E.ON I built a team for E.ON's first virtual power plant in the B2C sector.
Okay.
So when energy optimization wasn't that cool, especially not for households and small scale assets, my team actually started optimizing the first heat pumps in a virtual power plant back in 2012, 13, so a long time ago. And then things didn't really scale. Not because technology was not there. That was not the problem. We built a very nice virtual power plant. It was working. It could be traded. But back then, consumers were very skeptical. Why actually does anyone want to steer my heat pump? Was a question that we were always faced with. So the number of assets was limited because also you couldn't give consumers the benefits of what you did because there were no smart meters. And still today, if you want to be able to give an economical benefit to a consumer, whose assets you steer, you need to have a smart meter to be able to bill it. Back then, there were none. Consumers were skeptical what you did. And E.ON was not really in the space to partner with heat pump providers either, because E.ON was not a customer of heat pump providers, but was basically providing electricity to consumers back then. So it was a nice technology setup that we built, but we couldn't really scale it. And then I really started searching for jobs in the tech industry where things would scale. So what do? You end up
at Oracle.
You end up looking at bigger tech companies from the US. Apparently, Oracle was building a new hub in Amsterdam back then. I was living in Düsseldorf, so it was a train ride away. And within 4 weeks, I think, I moved from Düsseldorf to Amsterdam and started building a team in Oracle. And then went through very different roles, both in Oracle and Google, from sales roles of database options initially, to doing database transformations from on-prem to the cloud with my teams for bigger corporates in Germany later on in Oracle, leading the Oracle cloud business for Germany, changing to Google, helping startups scale with Google technology, and then actually meeting Philip on the OMR event in Hamburg.
Oh, really?
Yeah.
Oh, really?
Yeah. This is how it came. And then think
you did something in energy. Interesting.
Then we started talking a bit. And actually the question was, interesting. Philip seems to have a business idea that can scale in the sector. And I left the sector not because I don't love energy, because I really love it and I think it's a cool thing, but because at the time there was no business set up that could make technology scale in energy. And so it was just natural, basically, to go back to energy after a break in the tech sector.
Back at E.ON, you also did programming yourself, etc., or like how deep were you with energy optimization and virtual power plants? Like what did that mean? Like
back then I did even programming myself in E.ON, but also in university. So I mainly wrote optimization models back then, simulated the grid, simulated how energy plants would operate and what steering signals they need to be steered depending on what the grid needs. So yes, back then I was very deep into the programming topics even, yes.
And what does that mean concretely? I mean, like it can be somewhere between, I don't know, writing a very, very old language with like very old data, or it can be like almost real time. Like did it mean back in the days, and what does it mean today to do energy optimization? Like, is it today, like, I don't know, you have modern tools, you have IPython notebook, etc., and you, I don't know, build your algorithms and deploy them somewhere, or build a model and deploy it somewhere? And how did it look back in the days in comparison?
I mean, obviously the languages have changed that you work with. My initial work in uni was built in Fortran 990. So yes, very old school languages. Even back then, I couldn't find any books anymore. But this was how somebody started once the modeling of the energy system, right? I mean, today it's very modern languages that we use. Today we work in a Google Cloud environment. We use React, for example. We do a lot of modern stuff. We build IoT layers. We send live signals in 2-second intervals to assets, to 40,000 assets in the field. We see what they do in 2-second intervals. So it went from you do something.
40,000 assets, that's basically your solar installations, and or what do you mean by that?
By that, I mean 40,000 connected assets. So that is a solar installation, but that's also a battery. That can be a heat pump. That can be an EV charger.
Okay.
So a lot of different assets that all need to be steered in real time. Because if you look at it today, and what also the VPP approach has changed too from a 1,5 perspective. Back then, the VPP approach was you pool assets in a big pool, then this pool gets traded on the energy market for flexibility. So the main goal was you have a size of flexibility in your pool that you can trade. If you look at the more modern and more customer centralized approaches, you have a household that first you optimize the household towards what's the best for that household and the assets that you have. So meaning if there is solar production, if you can use it yourself, you use it yourself first. If you can put it into the grid because it's a good moment to feed into the grid, you can feed it into the grid. Or the battery, if it's empty, then maybe you want to charge it overnight because then the price is cheap and there's a lot of wind electricity, and then you use it again in the morning until the sun comes up and you have your own energy again. Okay. So the approach changed a lot from a very central pool where the consumer, you don't care so much about the consumer. The main importance is you have a big size of flexibility that you can trade, to a more consumer-focused approach where first you take care of what actually the consumer needs with regards to pricing, but also cleaner electricity and stuff. And then afterwards, you still have excess flexibility because you won't always need all of the battery. You won't always need all of the EV to be charged and stuff like that. And you can still, on top, basically make sure that what the energy markets or the grid security needs in a later stage, you can fulfill with your pool. But that changed a lot.
While you were talking, I just realized that we maybe went in very deep straight away. I mean, what 1.5 or 1.5 does is basically like first you bought like a lot of installation companies, right? To like install solar on different roofs. And then you also build that virtual power plant on top of that, right? Where you have a little device in all those households, which runs a software called Heartbeat, I think. And that does basically optimization locally. And then you do optimization also centrally, right?
Yes. So it's basically that was right. So the initial step was to acquire, and I wouldn't say solar companies, but electrification companies, because we have a mixed portfolio of PV, but also heat pump, EV and stuff. So it's a mix of companies to be a one-stop shop for anything that's needed to electrify homes. And that's also important for the steps that come later on, because I think if you want to bring the best solution, you need to have all assets connected in one system. And that's exactly what then Heartbeat does. As you said, we connect all the assets that the home has. They get optimized locally, but then they also get optimized afterwards centrally on the energy markets.
And now back to the actual optimization, And I don't know, I don't have like a concrete view on the energy market, but for me, it could be like sending out faxes to optimize, or it could also be Kafka. Like, are we closer to Kafka or are we closer to sending out faxes these days?
Anna, we are definitely closer to Kafka. What we need to do today is, even depending on the market you're acting in, you need in milliseconds to have a reaction of your pool.
Okay.
So now we again talk the pool level. So the household already is optimized. There's flexibility left. For example, in Sweden, we got a pre-qualification for something very technical, which is frequency containment reserve, which basically means in general, the grid needs to have a certain, so it needs to be at 50 hertz. And whenever it deviates from that, there are security mechanisms that usually were provided by big power plants. So they produced a bit more or a bit less, depending on how the balance was needed, basically. Mm-hmm. With a lot more renewables in the system and less power plants, also smaller assets need to provide that. But that needs to happen in less than a second even.
And who wants you to react in less than a second?
A grid operator.
A grid operator.
Because they need to stabilize their part so that not electricity gets cut off for a certain region or something because of a deviation from that 50 hertz.
Yeah. That's
the stable frequency we aligned on the European continent to contain our grids at, and they are all interconnected. So if it starts somewhere, it will have an impact across bigger segments. Mm-hmm. So you measure the frequency basically in certain areas. And when it deviates, automatically you need to respond in milliseconds and need to provide that response in a certain way. You need to prove you can do curves and stuff so that the system gets stabilized again. And that really, you can't send faxes because until the fax arrives, you can't even send an email. So whatever you want to do, you need to really have live control of your assets.
Yeah.
And that's where we are today at. And what is also needed. And then obviously, once you've done that, it becomes even, 15 seconds to do something on the energy markets and for economical reasons is a lot technically a lot more easy than doing that in a very granular way for the grid stability. And if you then bring both together, then you have the household level energy optimization for green electricity and for economic electricity, for the greenest and cheapest, basically. And then you have the pool level where you can still provide additional services, but they need a lot more granularity from the control, steering, and data than on a household level.
And how many grid operators are there? Like, let's say in Germany, like, is there one or is there 1,000? And like, how do they connect to 1,5 then? Is that like via a predefined API or via predefined market?
So it's a very that's a very complex landscape. Don't know how much we want to go into that rabbit hole. You can steer me, but it basically depends on which level of the grid. So high voltage down to low voltage, you're talking, because there are distributed system operators, DSOs, and there are transmission system operators, TSOs. Grid services get procured by TSOs at the high voltage level. So there are only a couple, like 4 main ones that operate, for example, the German grid. But if you go down to the DSO level, where it's about smart meters, where it's about changing smart meters, where it's about having data from smart meters provided in market communication mechanisms to be able to bill, you go to more than 800 in Germany. And that's a lot. So the high voltage level is a lot more standardized than the distribution system operator, whether it's not there's a central idea and processes how to work with them, but everybody has their own tweaks. So that's a lot of individual or bilateral work also with them to make the energy transition then happen on the basic level. And then it again comes to, if you don't do that, if you don't have the smart meter first to get a customer into a dynamic tariff, to be able to provide also a economic incentive of why we do that, of why we need to flexibilize local assets, you can't even think about providing the central services because you will like steer customer assets, but nobody will understand why or have a benefit from that.
And all the traditional energy companies want to block that, or is that? Can you say that? Like, because I'm building a house right now and I want to get a smart meter, but it doesn't seem to be that easy, right? Like it changes constantly, like how easy it is, and then you need spend at least 5,000 kilowatt hours per year until you get one, and then it's very expensive. Like that doesn't make much sense to me. That it seems like someone wants to block it somehow, or doesn't think it's meaningful.
That's another very complex topic with many different shades on it. So in general, this is actually why we went into becoming a provider of smart meters to our customers, because we didn't want to rely on others to prioritize the customers that 1,5 has. So if a customer becomes our customer, we also work with the processors and even come and install smart meters ourselves to make that transition work for the customers. That's obviously complex. There is a mechanism for that in German. Wettbewerbliche Messstellenbetreiber und grundzuständige Messstellenbetreiber. So very complex. There is a mechanism for that, but it's not an easy go, because obviously then you come and install in somebody else's area, kind of. Because usually you're right, you're the one that is responsible for your grid area, would at one point come to install your smart meter. But there's the priorities need to be set sometimes differently, because there are industrial customers that need to come first or stuff. So it's not at the speed that some end consumers would want it, and we can't provide dynamic tariffs or useful solutions to end customers if they don't undergo that process. So Germany, but that's also to say Germany is the only country where we need to install smart meters, because in all of the other 6 markets we're active in, the smart meter is the standard. In Sweden, even electricity prices in hourly grades are on TV in the evening based on the weather forecast. And you can come and provide our heartbeat solution and the steering without touching anything of the metering. And it's a process that just established and works. So it's very specific for Germany that there are some more hurdles in digitizing the energy world.
So we're the dinosaurs again, huh?
Yep.
I even heard that in the Netherlands, you kind of collect, if you have solar, you collect points and then you can charge your car for free somewhere else, etc. Like, is that true or?
That's a model that changes currently in the Netherlands, but it was called net metering. Basically, your meter run backwards when you feed in PV into the grid. And then if you consumed again, that was basically offset by what you feed in. So you had the grid acting as a virtual battery, which was nice for consumers. But in the end, with regards to the energy transition, it only works to a certain point.
Yeah. Because
you always need to consume when there's electricity. If everybody just feeds in midday and then consumes at night, okay, where does the electricity at night come from? It's not stored in the grid, right? So then you need to have batteries. So that's changing a lot in the Netherlands now. Thus also we are installing a lot more batteries nowadays in the Netherlands than initially when the net metering scheme started.
And in Germany, it's also changing right now, right? If you have storage at home, you can then charge your storage for free, basically, if you get energy for free, and then you can also give it back to the grid at other times, right? To a certain degree of your production facility or something, right?
Yes, it depends very much on your local setup and what kind of scheme you choose. So most customers still receive a feed-in tariff from the grid, and then you can feed into your battery from your PV, but you can also store into your battery from the grid at night when there are negative prices from wind, for example, but you can't feed in from your battery to the grid, because then you can't decide whether it came from your PV or from the grid. But then you can change your PV scheme and you can market what you produced due to the prices that are on the energy market. And then you can also always basically shift that production with the help of your battery to feed it in at a different point in time. But you need to kind of choose your schemes, but it's a lot changing in Germany, that's right. There's also a lot of, you need to have devices to be steerable nowadays, to be able to, or to be allowed not to reduce your maximum PV feed-in or production possibilities to a certain level to ensure the grid is not overloaded. So steering your assets and having somebody in control to do that for you becomes a lot more important if you want to benefit as a consumer also going forward in the energy transition.
Okay. Yeah, cool. I even heard that there are like companies investing into battery containers, which then trade energy for the investors, basically. Like if it's cheap, then they buy, and if it's expensive, then they sell, like automatically. That's super fascinating because like you don't know, like if you look at it, it doesn't matter to you, or you basically don't have a clue that this exists. And I find that super interesting, that space. And I can imagine that like also tech in that space is super interesting, actually.
Absolutely. I mean, in the end, it all comes back to physics, right? In the end, it all comes back to energy needs to be consumed when it's produced, or it needs to be stored. So if we want to stop cutting off renewables, for example, when there's too much, we need to store it somewhere. The prices, when there's a lot of renewables, it's cheap in the market because we usually don't use the electricity, all of it, at midday when all of the PV mostly feeds in, or at night when there are storms in the Northern Sea and all of the wind feeds in. So there is a price curve, basically, and consumption and production match, and that defines the price on the energy market. So like a normal market, but most consumers are not aware of that, right? So you're right in that way. In the end, still, you need to store it if you don't want to cut it if nobody's using it. And there's a price that also allows you to trade based on that. There's not a big difference between doing that with the assets that end consumers have and enabling them basically to do it for themselves. It's even better because you tackle the issues where they occur, for example, for PV feed-in, because everything you optimize on the household level, it will never cause an issue in the grid on a higher level, if you want to, because the energy never arrives to cause a problem later on. So there are different mechanisms, basically, on which voltage level, then again, you start tackling those problems. Yes, and one of the things that occur from that, because there's currently a market opportunity for those battery park operators, is to basically start trading bigger batteries as well.
Okay. Yeah. I don't know. Maybe I have to dig into that at a certain point deeper and learn how to operate a battery park. But now let's talk a bit about like your company and how you. I mean, you basically started off and there was nothing, or was there something already in software when Philip like hired you at OMR, or like what was the status quo?
There were already things happening. Back in the days, I would say there was no dedicated team that was in charge across the whole chain of things that we do. 1,5 does quite a lot of things. 1,5 and my team are responsible for mainly 2 different areas. One is our virtual assembly line, and we haven't talked about that yet, but that's mainly about digitizing installation companies, providing the right tools and services for companies that go out and install that renewable assets. Because the more efficient we can do that, the more assets we can bring, and so on and so on. And that's also the baseline for being able to integrating all those different companies. There were already things happening, but not in a centralized way, together with also what was happening on the Heartbeat side. So soon it's Heartbeat's 3rd birthday. Just when I came here, I was talking with my colleagues about how do we celebrate it this year. So there was already a first version of Heartbeat out there, but none of that was based on a common infrastructure, common database structure and stuff like that.
So more buy than build, I guess, also in many cases, or?
Yeah, or working with externals. So there was already build happening already, but then also working with external agencies at some of the points. And then my task really was to bring all the different things together, set up a strategy, and start building a team that handles it basically from end to end. Because in the end, there's a lot more value in the solutions that you bring to the customer and how you can optimize the assets if you already know how they installed. Maybe you even want to have a bigger battery, for example, in the end in a customer household because of how you can optimize, but then you need to plan it and calculate it already in the beginning. So having the data across the different systems, migrating everything to a single cloud provider.
So to Google Cloud then, I guess.
and standardizing, that were one of the first things that I did when I joined.
Yeah.
But yes, back then the team was less than a handful of people that really worked in tech in 1,5.
And what was your approach to hire the first 10 engineers to hiring?
I'm not even sure whether I started off with a fixed approach. I actually kind of started already with a backlog of people that said, I wanted to be part of that mission already, but there was no tech team so far. So can I be part of building the team? And then basically the first approach was, how do we choose the right 10 people to start rather than how to find them?
That's a luxurious problem. Well, I mean, right now, I think the market kind of also developed that way that like more companies have that luxury. But like back in the days, it was really luxurious, right?
Yeah, back in the days, it was really luxurious. And I really had the luxury to then find specialists and people that could take charge of a certain area. And that was, for me, the key, that I have a team. Not everybody needed to oversee everything initially, but I needed to have a team of people that can take a certain area, make sure that works, and then we align as a team basically across the different things. But the topics were so broad that it started from integrating CRM systems with what started to be our today's operating system that helps the companies to manage warehousing, for example, that helps the companies to know where to drive next and stuff, and to bring that together in a useful way and have a concept that works in business and technically. That was the first people that started there. And yes, also a colleague, later on. And at the same time, somebody that can understand, okay, what's the value of the data that we collect also for energy market optimization? How do I then start to calculate flexibilities and stuff, and to finding initially the right people so that everybody could take a ownership of one piece of the puzzle That was the initial start, how the team grew.
Okay. And just so you basically have that one big state machine, which is like solar installations, right? You you start a process somewhere and you end it somewhere, right? Like ideally when the solar is on the roof or even like feeds into the system. And then you have the whole energy optimization and heartbeat. Or do you also have different or additional building blocks apart from that?
There are building blocks because you can't see them completely separately. There is, when you look at the virtual assembly line, so how we bring solar and battery and the EV charger and the heat pump on the roof, already that kind of needs to be technically set up in a way that later on it will connect to heartbeat. Mm-hmm. So we only support certain providers, for example. We calculate sizes in a certain way so that later on it really makes also sense to optimize them. So both parts are interlinked. Also heartbeat needs to be installed, right? So heartbeat also is a part of the installation chain already. Also the smart meter needs to be installed. So there are processes of how to let the DSOs know that we go somewhere to install a smart meter at a certain point in time. So it's a complex process machine that already enables also the installation of heartbeat and thus later on what heartbeat does. So it's not really two separate parts, but there is a part that is the enablement of the installation and basically making the system operational, like the assembly. And then there is a part that is over the lifetime of the system, it does the optimization and offers new software solutions to the customers that are online.
And then that CRM building block part, or that state machine that I described, like there are like then how many companies do you own in that installation space?
More than 80 locations.
More than 80 locations.
In 7 countries.
And can you like dictate them what to use? Like, does that work? Like, because they are like, I mean, they did it a different way, like for ages, and then can you tell them, hey, you just use this and you'll be happy? Like I send you a mobile phone and then you use that mobile phone to get installations and know where to drive, etc., and then it's all okay? Or is that not that easy?
I think today it's all okay. Originally, when we started doing it, there was a lot of skepticism. And it was more a project of working with everybody to understand what the benefits of that will be. But it was not a straightforward thing. You don't like come by a company and say, now we change how you work, because they were also successful beforehand. And the software team needed also to understand first what does really matter and how do I shape the processes to not destroy what had been working before, right?
Yeah.
So it needed a strong team to be formed from people from the business that knew how the processes could work, that were able to standardize them, and then a team that would understand the requirements of that and put that into software in the end that would automate and digitize those processes. But no, it was not, this is the solution I built in the cellar with the initial team, and then we go out and roll it out and everybody's happy the next day. So it was a process. And I think it also took really some entrepreneurs that said, I'm just gonna trust you and your team now. I volunteer for doing a trial. Mm-hmm. I volunteer for migrating first. And then when you had the first 5, 6, 7 on the systems that gave feedback, but then assured the others that it's working, you kind of got that movement of doing it. And it changed by now even more to a situation where in certain countries, parts of those systems are still in rollout and definition, because then countries have different requirements. But now it more changed to, why can I not be taken care of first? Why do you still work with company XYZ now? So we have a very different discussion on that today, but it took us also those 2-3 years to get there, and also to convince people that we are different in that sense, that you don't call somebody and then somebody provides an ERP system and has thought about the process themselves, but that it's a joint project to develop actually software that then enables the businesses to really have a solution that fits their needs.
But generally, the result for the installation company is an app, basically, right? I at least imagine, or
the result for the installation companies are many things. It starts with a centralized CRM system. And then also from the CRM system, once everything is sold, we go into our operating system that really does integrate with technical plannings. There you see which components are in which warehouses, what's the schedule, who from the team is going when, where. It does post-margin calculations. It is also an app somebody goes to on site. And then kind of does the protocol of that everything happened according to how it should happen.
Takes photos, etc.
Takes photos, so we can have a look in case of warranty issues with the suppliers, for example, of the hardware on how that works. So it's a complex system by now, and it's not one app. It's many applications basically that for the users are integrated and hand over the data from one to the next one.
And what's your general stack in the background for this whole installation space thingy? I heard that you partly even use Ruby, so you potentially hired a dinosaur like me, or what happened there?
We partly even use Ruby. Yes, that's correct. We have a mix of a stack also because of the history of what has been there and what hasn't been there, basically.
The brownfield.
Because we have also, yes, obviously, if you acquire lots of companies, it's not all a greenfield. Yes, we are a startup, but we also came with a history. We brought together different things. Yeah, and we also work with the usual tech radar, and Ruby is definitely not on the let's roll out more of Ruby, but it also is a core of the system that is running and it's working, and we have a team working with that. And I wouldn't call them dinosaurs. It's quite a cool project as well.
I actually hope, I still find it very productive to work with it, but I actually hope that like some fresh people also move into it still, because that's the main problem with, like, from my perspective, the talent in that space, that like everyone learned it 15 years ago and now it's a bit outdated, and the people are actually like more the older one and the more, like, let's say, conservative senior developers than the younger fresh talent who want to use, I don't know, Node, Rust, whatever.
No, we really have a mix also in the Ruby area. You can come visit us in Berlin or Hamburg if you want to and meet the team. It's a bit like 1,5, right? There are many pieces to the puzzle. Also, the team is very diverse, but it has nothing to do with dinosaurs, also not in the Ruby space.
I can just imagine that it's super hard because that space is kind of not standardized, and you buy many small companies. Not everyone even uses Datev. And not everyone even has like potentially a good financial system and like stuff on paper, etc. Like, how do you standardize that?
I don't think that's different from the rest, right? So it's one more system in the things of that you need to change. It's a big change project. We talked about that before. The companies that we buy, most of them don't use a CRM. Yeah. Most of them have no warehouse operating system. Initially, they are a small installation company. If they need to know what's in the warehouse, they go and count. Yes, then there are bigger ones already in the mix that have some kind of software that then either we change or integrate with, and it's the same on the financial side. You have those companies that are so small that they don't have certain requirements also, as long as they are that small for themselves to establish. But when they become part of the 1,5 group, also the requirements on the financial side change. And then also the systems with that need to change. Okay. So we really have like a post-merger integration operation, basically, whenever we acquire a company, to change the way they are working, but not because it has been bad before always, but also because
you have to be compliant, right? You have to be compliant. Yeah,
we are bigger companies. There are different requirements, so there is a need for that change, and on the system landscape sometimes also.
And out of curiosity, like, do you have then like a big PMI team that like jumps in and works with the company for a while, or do you tell them like you have to change this and this and this and that, or how do you do that? Like, how deep do you go in?
In the peak of integrating companies, there was a PMI task force that went and helped companies to work on site. Mm-hmm. Nowadays, where we have a lot more of organic growth, also in locations, than only acquisitions, There is still a PMI team, but it's also a lot of we anyway do retrainings, for example, for software. And then the product managers and the rollout teams of software that go a lot more and work with the companies than having a real task force. There was a time when we really had the list of priorities, and then the post-merger integration team really worked for a long time on site with all those companies. But nowadays, with blueprints, with an established system landscape, and having done that more than 70 times, it requires a lot less effort also from central teams to make sure it works. It still needs training. It still is a people business also, because it's about changing without breaking stuff, and also taking the people with you on the system change. But that changed also a lot from how we approach that, with the maturity and the know-how also that we gained on different processes.
Yeah, I can imagine that it's super hard to get to a decent quality of teams, right? Because everyone obviously is, or many people are acquired or came in through acquisition. And I mean, I'm also acquiring companies personally, so I know that you get you get a mixed bag always, right? And then ensuring that you everyone is moving up to or down to a certain bar that you want to reach can be super, super hard.
Yes, and I think again, what helps is the joint mission of where you want to go to, because to become part of the group, there's also a willingness to become part of the mission that we are on and to provide the solutions that we have. So it's not like if I look back to the Oracle days, for example, there maybe you would do an acquisition solely for technical purposes and not because of the team that is behind something, but the technology was a match, right? And then it's a lot of a different process, as if you also want, or as if you find also people and have part of your due diligence, basically, what's actually the fit to the mission. And is the team that becomes part of 1,5 also willing to make the changes? And then it's still not easy, but it's a different story, because we all know where we want to go to, bring the cleanest and cheapest electricity and change basically the energy world with that. And then there's a different motivation coming with it.
Sure, but I mean, if we're talking about hundreds and thousands of people, and then just aligning everyone on a mission might no longer be always possible, right? You have small centers, you kind of have someone leading it whom you trust, and this person has to make sure that or this team has to make sure that people below them are also delivering into the same mission. But ultimately, I guess you also have something I don't know, benchmarking, KPIs that you use to kind of align on numbers as well.
Definitely, and it's 2,500 people by now. So yes,
wow.
Yeah,
that's a lot.
It's quite some people that work on that mission. But of course, the benchmarking also helps to identify in the end. I mean, I look at it from a very process and technical perspective, obviously, but also the benchmarking helps to identify who actually has the best process that we should implement, because something is working. And then once you have the system, it helps you to measure more granular and more detailed of where actually does somebody else need more help from the team to become even better, basically, in providing solutions. So yes, absolutely. Having 2,500 people on the same mission is not the easiest. We also changed organizational structures a lot on the way, with having regional hubs, for example, that are responsible then for certain locations and work with them to make it manageable, because you can't talk to 80 locations every day and figure out what's going on. It needs to be standardized and it needs to be automated. And yes, that's a long process that we went through, and we are still obviously on that process to continue with it.
That's super cool. And what's your approach to scaling across different countries with very different infra setups? I can imagine that it's not you already mentioned that there are parts that need to be adjusted per country, etc. Do you have different infrastructures as well, or is it all centralized and then you do the country rollout and you can still use the same central infrastructure, or how does it look like?
Yeah, we can still use the central infrastructure. So far we are even running Australia still out of one central infrastructure. We might need to change that at a point in time, especially for APAC basically. But today and for Europe, there is a base setup, and then the customization is rather happening on the application level. So what are we optimizing against? What are we allowed to do in the regulative market? What are the taxes when it comes to CRM? So there's a lot of customization happening, but none of that so far is done on infrastructure level.
Okay. That's good. Like it could also be much more mixed and much more tech debt. So it looks as if you have like a relatively modest amount of tech debt, which you also created yourself, and you don't buy tech debt from others. Because that's what you can replace basically in the PMI process, right? Like if someone is using Lexware, then you can tell that person to replace Lexware with like your own ERP or whatever, right?
Yeah, but exactly that's what's happening. So in the PMI process, I mean, for the heartbeat side, there is no legacy in the countries anyway when they start with us. And then on the virtual assembly line side, that's what you said is exactly what is happening. We migrate the companies to our central setup, and then we replace the systems that were there with what we set up. So Australia is using the same setup in the CRM than Germany, for example, other than localizations that are needed.
Cool, very good. What's the? I guess you replace like many Excel sheets with kind of like processes, or replaced many Excel sheets with processes. What was the craziest Excel sheet that you've replaced with real software?
The craziest Excel sheet. I don't think they were too crazy, actually. I would rather say the craziest thing was to have data transparency across all the different branches for the first time when the CRM rollout for Germany was finished. I think it's not crazy, and the Excel sheets were not crazy behind that, but to see actually how many projects are we currently working on, what is the status of them, and have that transparency for the first time, that changed a lot. And not having to call somebody and ask what is currently happening, where do you need help. I think that was the biggest like structural change basically in how we worked. The companies that we bought when they were small, they were working in Excel sheets, but when they were bigger, they had different systems already. So we also replaced, for example, companies that were on a different pipe drive setup with our Zoho setup. So it was nobody did crazy stuff in scaling only on Excel sheets. So when anybody got to a certain size, they obviously needed to do stuff on their own. We even acquired a company that built a offer tool themselves. So how do they combine offers so that they can be sent in a nice way to customers, and calculations are automated. So it's not that nobody did do anything beforehand and everybody was working in Excel. It was just not standardized and not the same in all the different locations. But I wouldn't say that's like there was no crazy Excel sheet like back in the days when I started trying to solve some optimizations algorithms, and then you would have Excel calculating for 3 hours. No, I didn't see any of that happening when we acquired companies.
Okay. Understood. And do you have then it's like you have a BI team somehow that also does like data transformation, etc. But you don't have a huge variety of data sources where you have to get the data from, because all the data sources are basically provided by yourself in a way to the business already, or?
Interesting topic, actually, because that was the only team that was so our BI team, we have a BI team, and that was the only team that for a long time was allowed, I say it that strictly because I was quite strict initially, that was allowed with whatever was there. Because when you first want to have the first version of your reporting, you can't like change every company at the same time in a second. So that was the only team basically that did an integration on this pipe drive there, a different setup of Zoho here, and a different system there, and an Excel sheet from someone. So the BI team actually did a lot of the initial puzzling. Nowadays, their job is a lot different because nowadays it's really about standardizing the data so that business users even can build their the dashboards on their own. But initially, their job was to even understand how to bring different data sources, not only technically, but also from a business perspective, into something that can be used.
And how to standardize it, right, to a certain degree. And then what is the new standard structure that you roll out? And there, I guess you also use like standard tooling, like DBT, stuff like that. Plus, I guess, Looker, if you
yes, we are fully on the Google stack, so you got the point. Correct. Yes, the dashboarding and everything then happens in Looker, and that's what we work with. Baseline is Google stack, and that's what the team, when possible, works with.
And also, I guess, for all the other, like you have the, let's say, boring standard stack that everyone uses these days, right? I guess Kubernetes, and then like that's it basically, and many cloud tools, I assume more. Okay. It's not so interesting to talk about infrastructure these days anymore, right? Because like basically things are commoditized and standardized, and sometimes there's like a very big important technology in your stack that you really have to take care of, and that's it, right?
Yeah, and it's also one of the first teams that we founded because we knew we're gonna have a lot of different applications running. Was actually also the central platform team. So I have a central platform team that basically from day 2, I would say, onwards, built infrastructure as code also and did standardizations across the different teams. They also run our standard data setups, and the BI team is part of that team because that's kind of services that all my then development teams of the different applications will need. And we had the chance there, we were really greenfield, right? We had the chance to build that how you would imagine it to run in a company and not try to then bring together, oh, there is something running on AWS, somebody has something on-prem, and there's a different thing happening. But there really a team could standardize how we do things in that space from the very beginning.
Yeah, that's actually a challenge that I have with acquiring different SaaS companies with way different stacks and different setups. Like everything is different, but that's a luxury as well. So I'm a bit jealous. What's like slowly coming to your end? What's been your biggest or last big aha moment, either technologically or organizationally, like anything that made you, like a technology that made you way more productive, or something you personally for yourself, like how you structure your day, or something you learned that others should know and that others can also adopt, and that like really made you say, aha, that's I have to tell all my friends about this.
I think the latest thing where I thought it made a big difference that we didn't see initially is actually formulating prompts with the help of AI that explain what we do. Because a lot of the time beforehand, there were customer requests on why did XYZ happen in my system, and somebody needed to answer to that. Then you need to have a certain know-how on the optimization. You need to look into, why did the battery not charge at night? That's because there was a PV forecast for 6 a.m. Why was there still grid consumption? Because there was no sun. It came an hour later, and then there was a small amount of grid consumption. And to explain that to a customer, initially, that really took a lot of capacity off the teams, because you needed to look into it case by case, kind of. And then with bringing just the decisions on why the system did something and making them transparent in a phrase to the consumers, that changed a lot. That changed a lot of manual effort.
As long as it doesn't hallucinate, right? Like that's it could be a challenge then, right?
But as it's a lot of, so as the decisions are a lot of machine learning and bringing together different data sets, it's not like, the decision comes out of nowhere, but there's usually a rationale. And then if it looks strange afterwards, it's because you never have perfect foresight, right? And there might still things happen later on that you didn't foresee when the decision was taken. Basically, like there was no sun in your specific location in that initial hour of the day. And then retrospectively, yes, you could do something different, but there is not that perfect foresight. And explaining that to consumers and to our customers, that changed a lot, because it just freed up a lot of people that were looking at different data sets trying to explain, because the optimization and the decisions are taken automatically anyway. But then if you want to explain them, you needed somebody to interpret that understood why they have been taken. And that made a big change.
Yeah, I can imagine. Also for customer support, basically, right?
Yeah.
Like that's that sounds great. Slowly coming to my final question. Imagine, like, I don't know how many movies you watched, like back in the 90s, like there was like always this idea of having this supercomputer that has this red light shining, pulsing while it was talking, and you could talk to it and you could ask it for things. And let's imagine like Heartbeat was that like supercomputer that is somewhere in a Google data center or whatever data center running, and invented by Philip back in the days. And it actually is capable of sending you to different times back in the day. So it's a like really magic device, time machine, and we now have the chance to travel back into your 2010. I think you were still like a student working on your first energy optimization models. And we observed yourself for a while, and you now have the chance to whisper something into young Barbara's ears. What would it be?
Just go for it. I think back in the days, I myself was struggling a lot with how far can I come and what are the possibilities. Also because the lack of female role models in that space. And I wouldn't have thought that back in the days I would today be the CTO of 1,5 in the energy space. And I would just tell myself to don't reflect, just go for it. I think that's a lot easier. You spare yourself a lot of double thinking and questioning of whether something is possible or not. Mm-hmm. If you don't try, you will not know whether it works for yourself or not. So yeah, that's that. I would whisper that to myself.
Okay, yeah, very good. I can imagine like explicitly that female role model problem is a problem actually, right? Like I have 2 daughters, and I also like the first things you learn in school is that you're bad at math, and like electricity is not super female dominated, I guess, like even worse than like engineering, I assume.
It's probably about the same, okay. Or worse. Yes, and there were no role models back in the days, and I had the courage also because teachers in school just told me like, no, never mind, you can do it, you go. But I would have wanted to have more role models in that space to make decisions easier. So that's also why today with Sophia, we try to build a community of women in tech and energy, for example, and try to bring more confidence to that space, because it's super interesting, right? You can have a big impact in that area. But it's not female dominated. I think in my studies there were 2% females in Aachen back in the day.
Wow, yeah, that's bad. And great that you're changing it, because I think this really is a good mission, and is really important to get like diversity of thought into all the different areas we have here, right? Like engineering, electricity, etc. Like you can achieve more if you have like different people involved, and I really appreciate that a lot. So, that was really a great discussion. Like learned a lot about energy, like not so much about tech stacks, etc., but a lot about energy and how it actually works. So thanks a lot for all the deep insights. And one last question, like as I said, like I'm building a house. Like, can I also like just buy parts of your infrastructure or parts of your technology, or is that like really like a closed shop where you have to do everything in the house to be able to operate a Heartbeat or whatever?
You can also buy parts of it, but not everybody will always work with our systems, because we need to have the ability to steer something. So you will at least, for example, have a battery that we can steer. Otherwise, we can't really optimize. And I think that's also the challenge with a lot of solutions that are out there. Then you can see data, but you won't get optimized. Or if you don't have a dynamic tariff, no optimization can happen. So you need a smart meter for that. But if that comes from us or if it comes from a third party, that's then not the decisive factor for that. But we need to be able to steer something. So if devices are compatible, if there's a battery we can steer, if we can bring you on a real dynamic tariff that also can be built later on to you, then you can join also, if not all of the devices come from us.
Okay, yeah, cool. I will call you then. Thanks a lot for being my guest and thanks a lot for the good discussion. Hope to see you soon. And yeah, engineers, apply for the interesting roles that Barbara has in her team. So I guess that's what I can at least contribute here. So
thanks a lot for having me. Very fun discussions. Cool.
Thanks a lot. Bye.
Thank you for listening to the AlphaList podcast. If you liked this episode, share it with friends. I'm sure they love it too. Make sure to subscribe so you can hear deep insights into technical leadership and technology trends as they become available. Also, please tell us if there is a topic you would like to hear more about or a technical leader whose brain you would like us to pick. AlphaList is all about helping CTOs getting access to the insights they need to make the best decisions for their company. Please send us suggestions to cto@alphalist.com. Send me a message on LinkedIn or Twitter. After all, the more knowledge we bring to CTOs, the more growth we see in tech. Or, as we say on AlphaList, accumulated knowledge to accelerate growth. See you in the next episode.
Dieser Podcast wird produziert von Podstars bei OMR.